Thanks everyone for joining today. Again, as Nicole said, my name is Zach Sample. And if you're, unfamiliar with myself, I've had a bit of an intro, but if you're unfamiliar with XP Solutions, our group kind of as a whole, I'll introduce our group a little bit here. So in short, XP Solutions, we provide original high-performing software solutions for the principally the civil engineering industry. Okay. So we're really leading the industry, as I'd like to think of it as, leading the industry in our customer service and support. That's something that I was heavily involved with for a number of years, and still something which I pride myself on our organization doing. So today, this is the third part of our detailed webinar series, and so we're going to look at reviewing and reporting drainage projects, and really how you would do that with XP Drainage. So we've looked at how to start a project, how to kind of lay out your initial drainage plan, and then that was the first of the webinar series. The second one was focused on, the actual design. Often the majority of the time you're going to spend on a project designing, optimizing, iterating through different versions of your plan. That was the previous webinar, both of which, like this one, will all be available on our website. If you didn't catch those, you can go back and look at those on our website. So today, reviewing and reporting. So we're going to look at really what to review. So what matters with a green stormwater infrastructure project? What do we care to review? And then how we're going to review and report with XP Drainage, and pretty quickly get into actually walking through the software. So the first, what to review. So I'd say the very first thing is often the start of our design process is to meet the water quality guidelines. So how do we treat this, the water quality on our site? That's often, performed by this runoff reduction practices. So does the volume that we need to treat with runoff reduction, well, is that being treated? So beyond just the runoff reduction, that water quality event, that's something we're going to start with knowing and understanding. Well, of course, there's a whole range of other rainfall events which will take place. So we're going to look at perhaps what we might call these protection events, the 2 through 100 year overbank, channel, flooding protection events. And we're going to look at those versus, of course, the existing conditions. Now, this might vary based on where you're at. The trend is becoming, a bit more strict as far as design goes, but certainly for years and years, the basic stormwater focus was on reducing the discharge rates off a developed site. We're beginning to see a lot of groups, a lot of municipalities, a lot of university studies showing how important it is to control the volumes off of our site. So for many groups now, not only do you have to control the peak rate off your developed site compared to the existing conditions, but also now you can't discharge any extra volume. Okay, a bit of a hydro geomorphology kind of viewpoint. So hydromodification. So beyond just the bare minimum of do we meet the volume to treat our pollutants, and are we not creating impacts beyond what the existing site looked like? Well, is our drainage system connected appropriately? Sounds pretty basic, but often really difficult to see. In the last couple webinars I looked at all the different tools that we might commonly use to perform this kind of assessment. We might use 3 different spreadsheets, 2 different software packages, and perhaps AutoCAD, let's say. So that's, let's say 5 or 6 different tools. A lot can get lost. So actually seeing if the drainage system is connected appropriately is sometimes quite difficult to see. Another one might seem obvious discussing it now, but in practice can really slip through the cracks. Does the proposed drainage design actually fit on our site plan? Right, so this is a bit of that back and forth. The drainage team, well, here's my proposed pond. Here's my proposed rain garden. This is how big it needs to be to control that runoff reduction, water quality volume, or perhaps that 100-year event. Great. So you hand that spreadsheet off to the site team. What if, I guess, what's in that spreadsheet really doesn't get represented kind of in that plan? Okay, that's an issue. Do the green infrastructure facilities, the stormwater controls I might call them, do they actually meet regional standards? Okay, so you might have your own tools or spreadsheets or older tools and spreadsheets by a city or municipality that maybe don't reflect the current standards, the latest releases of I guess their documents. And really the last one, I touched on it already once, but it is, in my opinion, the easiest thing to, I guess, have be kind of the mess up that could occur. Just simply not having the design calculations actually make it into the plans. Okay, so not actually having the pond, I guess, be the volume storage that you are designing towards, then what actually gets put into the design plan, which will get built, right? So that construction document set, well, it doesn't really match what your assumptions were. So those are all the items that I'd say that we need to review. Some pretty big picture items, some maybe more specific ones. I want to maybe launch a poll just to see what your opinions are. So we have a couple options here. This is just simply, what's your preferred way to review or vet a drainage project? So what do you like to look at? What's important to you? You can pick more than one. Long sections, profiles, tabular views of input, of course, graphical time series chart, and maybe the most standard thing is just simply having documents, plan sets, CAD GIS plans showing the layout. All right, it looks like everybody is voting here. I'll give people a few more seconds. All right, so let's take a look at what everyone has said. So I'll just close the poll. And I'll share this so everyone can see. So pretty interesting. The majority of people said, everything that I listed there is something that they want to use or do use right now. And pretty even split of, if not all of these, the individual components all seem to be pretty important. So it seems that any solution that doesn't really provide all these options is going to be want, I guess, for a bit of our review. So very good. So very interesting stuff. So let's look at just the results output from XPDRAINAGE. So what are the different things we're going to be able to look at? Of course, we're going to have a tabular view of information. So we have something I'm actually going to show the soon-to-be released version, the 2016 version, which will be released in just a couple weeks in April, which has we call XP tables. It's going to show all of the different tabular input into a model, which is part of that kind of just vetting that what you are proposing, meets those local standards, whatnot. But of course, tabular results are something that is in the current version in a number of different ways. We'll look at that. So tabular output, graphical, okay, pretty obvious. Graphs are great to show us the trends and nothing more. So there's a lot of we could maybe look at a graph and okay, well that line begins to taper out and here's the maximum. I always say in the trainings that I give out, seminars that I perform, it's the tabular result is really the way to look at the maximum, and the graph shows the trends, how the system will behave. So that's really important. And we're going to have a direct output of that runoff reduction, kind of beyond those two. And one thing we haven't seen before that I haven't showed that's in the new version is the 3D view of a site. Can be helpful. So we'll see. Be interested to hear, I guess, from you. You maybe update something in the questions when we start looking at the 3D views. What you think. Just another kind of tool and toolkit, so to speak, for reviewing a model. So we'll look at that. So that really covers a lot of the different kind of results output types. Okay. Now, the other bigger picture items we're going to be looking for is input mistakes. I already mentioned the tabular input of data is a really great way to look at that. And also, how do you look at results for these multiple or complex structures, be it outfall structures or just how multiple different kind of flow connections, pipes, let's say, all drain into one system. So seeing a breakdown of inflow, outflow for facilities, depths, that can get quite complex. So how we would look at that. And let's just jump right into a model. So this is the model we've been working with over the last couple webinars. So we've run this model, and when you run a simulation, the very first thing that's going to pop up is this stormwater control summary. Okay, so this has a bunch of information, and you could ultimately kind of whittle down the columns you want to see under preferences. We could change what's shown. But this tells us a lot of information for all the stormwater controls in our system. So we can see, move that away, we have a number of different rain gardens, swales, pond, even these porous asphalt areas. So really, what is the first thing at a glance that I would want to know about? Well, if you go to the right side of this dialog, well, there's something that says OK. Well, it might not make sense. What if I was to change the rainfall, the storm selector? We'll see this as flood. So we're also going to see something that says, maybe like at risk. So this is if the water level gets up to that freeboard we've designated in one of these controls, that's going to say at risk. So it's not overtopping, okay? Obviously, okay would be that it's kind of below the freeboard. If it gets above the freeboard, well, that's flooding. Now, immediately next to that is percentage available. Okay, this might be one of those really obvious things to have, but having it presented like this is pretty unique. So for the water quality event, this 1 inch of rainfall, you'll see that these facilities really kind of aren't fully optimized, right? They aren't fully, I guess, topped out in that water quality event, which is what we want. So we designed this site to treat and infiltrate the water quality event, but then safely contain and pass the higher events. So for a water quality event, we're fully containing and treating that flow. As we go to the 5-year event, you'll see, well, right away, flood risk or flooded items. All right, so I made a number of these configured in a way where I actually took out a bunch of the outfalls, so we'd see some pretty catastrophic flooding. But even just from these two columns, we get a good idea of how well our facilities are sized. So from that, I might know right away my pond, you see this here, in the 5-year event, well, it's 65% full. Okay, that's pretty good. And again, my dry pond here, it's just about 50% capacity left. So this pond is much too large, right? That's what I'd gather from this. So I could perhaps change my outfall structure, change the size of that pond using some of the design tools we used previously. Right away, that's what this dialog is going to tell us. You can also get into actually seeing the depths, inflows, outflows, so on and so forth. So this is kind of why this dialog pops up for you every time. This is a really great at a glance, seeing where the kind of max water level was, or really just the capacity in those facilities. All right, so what's next? So we looked at just that at a glance of stormwater controls. We could do the same thing for just the summary of all of the model items. So we have this list here of all the inflows into the system. So all the catchments, here is the area, here's the inflow rate into our system, and here's the volume, okay? So all these tools I'm showing you right now, they can obviously be looked at for reference while you are modeling, while you're doing the design. Any one of these can be printed, can be reported. So that's, I guess, the vetting and reporting kind of go hand in hand. So any of these items, like this inflow summary, well, this would be a table in my report, right? So I would have this information. Here's the name, area, inflow, and volume. Perhaps that's table, R5 of my report being the kind of catchment breakdown. We'll look at some other ways to show breakdown in a second. So inflow, something else would be the connections. So if I wanted to look at the connections, in this case, these are all the pipes or channels in the model. So here is the connection type, has a pipe, trapezoidal channel, what have you. and then which two objects does it connect to. So it goes from this item to this item, it goes from a manhole to a facility, inflow rate, outflow, and capacity. This is really kind of where you'd see how well designed a system is. So in this model, I have very, very small flows. And I think actually a better example is this here, where I can show you. Remember I removed a lot of the actual connections and outfalls in that first model I was showing you, so that I could have that really big catastrophic flooding everywhere, so you could really see what was happening. This is just the same model before I removed all of those items. You can see here flow capacity, so I have a 10-year event. This might be what I'm designing towards. You'll see the default pipe size I use, be it 12-inch or 18-inch pipe. That's going to safely convey a lot of this flow. In most cases, you might have, let's say, a stockpile of 12-inch pipe or 18-inch pipe as kind of your base, and if it needs to be upsized, obviously you'd do that. So what we're looking at here is, well, all of that kind of default pipe that we have laying around is going to convey our system appropriately. If these start to get up pretty high, 80–90%, we might begin to look at if there's a better way to maybe upsize the pipe, multiple barrels, what have you. But this connections summary is really useful, again, to, at a glance, really see everything happening in the model. So we've looked at some summaries. Now we can maybe look at individual performance. So one item here, let me go to the other model. I had something I wanted to show. So for example, if I go to one of these stormwater controls and we could pick, let's go maybe to just a random green street system. So you see we have lots of information here. And what I wanted to show in this model was the pollution concentration over time, that loading and how it's reduced. So we could, of course, change the display of what you want to look at. You see here, this is a volume graph, that's a depth graph, this is the flow, and I could turn these off. Maybe I don't want to see anything other than the inflow and outflow of this system, or inflow versus the rainfall. You see this is a very small facility, pretty well follows suit with the inflow into that part of the model, right? You could, of course, turn these off and on. Perhaps more important, more useful would be looking at the breakdown. So maybe this is the detail that only for a couple specific parts of your site you want to dive into. Maybe I'll look at that downstream-most pond. So my pond being, right, the high flow 100-year event. This might be the hardest to get a picture for how this is all working. In my model, I happen to have a pond which has a number of different inlets. So we can see here, in this case, there's 3–4 different inlets into this system, and then kind of one complex outfall. Well, we could look at total inflow or, right, individual inflows. You could look at each time series. You can also look at kind of that outfall, if there's multiple outfalls of that. Really as complex as you want to get, all right, we can dive into. You can see a time series. This started wet. This pond was half full. That's why there's outflow initially. And then we begin to have flow into the system, and then it continues to drain out. Of course, we have pollution summaries. Again, as I've talked about previously, a lot of the actual pollution modeling we often ignore. Right? We're going to do that runoff reduction assessment. We're going to make some assumptions that the first inch of runoff is very polluted, and that contains the vast majority of pollutants. So if we just contain that volume, we're fine. That's a volume assessment. If you actually want to look at pollution wash-off, pollution treatment, well, clearly we can do that, and this would be one of the reports. You could see inflow, outflow, reduction. You can see clearly we have a significant reduction through this system. So if we go back to the soon-to-be released version, we'll see I'll go back to this pond. And one thing we could look at would be this 3D view. So I can zoom in, I could play this through. You see this pond is is wet. You get a little bit of a transparent view on the side with this wide basin. Well, there's not a lot of kind of fun, exciting items here. It's just kind of a wide pool. Of course, we could still change this display. Right-click, make it translucent. You kind of see through the side. So pretty unique. So I'd be curious if anyone, you know, as we go along, or maybe at the end of the presentation, questions, comments. Would love to see if someone says, "Hey, this is pretty neat," or "Yeah, I don't think this is quite useful." I'd be curious to see. This is the first time I'm presenting this. This is some part of that new release. Curious to see what people's reactions are to the, I guess, 3D views. I can show a different one. Pond might not be quite as exciting. What if I picked one of these? I'll just pick a random bioretention system. So let's go to the 3D view of the bioretention. Again, these little green street systems, vertical walled with filter underneath and a drain pipe. You'll see if I begin to play this simulation, how this fills up. And this really does do a great job of showing the, I guess, kind of the purpose of why XPDRAINAGE started out. The idea of handling the flow through the filters, flow from the ponding zone, right? So the area above the filter ponding zone, well, obviously flow through there, kind of like a swale or a channel, but flow down through the filter media into that pipe. You know, tackling that is really the backbone. That's where we started out with XPDRAINAGE. So this gives you a great view of how these systems will fill up. And we're seeing here this little indicator in the 3D view showing us that we're flooding. So if I step it back a second, you might see an orange. See, it's orange. It's within the freeboard. And then, you know, over time, well, this is actually a flooded system. Okay, so that's a problem for us. Again, with no, you know, high flow bypass, well, I would expect it to flood in the 100-year. So I could maybe, you know, zoom in. Here's the under drain pipe. Change the transparency. Okay. So pretty neat stuff. Again, these are different ways to review what in the world is happening in your model. Okay, so pretty interesting stuff. Again, that kind of 3D view, you know, we're talking a lot of cases of our spreadsheet tools just really not being enough for us. You know, this is certainly, you know, a couple steps above a spreadsheet. Being able to assess your model, quickly design it, well then also actually see the 3D interaction of your system. So pretty neat stuff. Okay, so we can obviously dive into a summary of, you know, all the system, all the different like items, all the pipes, let's say how all the pipes work, or all the stormwater controls. Dive into individual items. Something else we could do would be to look at, we're going to call it the phase report. Okay, so this phase report is going to look at, in this case, I've shown previously, we have different phases that I've assessed. So I have an existing phase and a mitigated phase. The one in red means not being assessed. That was one that I was using just to kind of build up, and as an example. I have my completed mitigated phase or scenario here. So I can compare these two, and this is how I get that direct existing to developed comparison. So phase report, I could select what storm event I wanted to look at, let's say, update the view. And again, in this case, I'm not showing pollution, but obviously I could. So this gives us a really great breakdown of, you know, really what we'd want to see graphically, inflow, outflow, rainfall. You know, we could adjust what's shown in these results. The best thing here, again, is kind of that tabular snapshot. Graphs are going to show us the trends. We get into existing versus mitigated, you know, total system discharge and volume. So great. So in the water quality event, we have, you know, in the existing event, we have outflow from our model. Okay, well, we're going to say in the existing phase, the water quality event, we're going to fully contain that, and that's what we're doing here, right? We can see we have, you know, 20,000 cubic feet of runoff. You know, that's almost a little more than 19,000 cubic feet more than we used to have. We're fully containing that because there's no outflow out of our site. We move to some larger events. You know, we can interact with some of these graphs. We can change the table being above or below. This is great if you actually wanted to kick this out to a report. Any of this stuff could fit into a report. Here's your summary, here's your charts. We get down perhaps to the 100-year event. How is the system performing? It's doing great for the water quality event. Here we can see a breakdown of outflow in the existing phase, almost 18 cubic feet, but you know what? We're actually going past that. So we aren't retaining enough, we aren't attenuating enough flow. Our mitigated result is 18.2. So we need to restrict that flow. I mentioned our pond isn't quite full. It looks like we're discharging a little bit too much, so we need to restrict that further. Though there's also the volume summary. So we're holding on to too much volume compared to the existing, but we're letting it go too quickly. So that's what this chart gives us a breakdown of. So something quite useful, I've mentioned the runoff reduction, I've mentioned kind of that water quality being something we've designed with. Well, the same tool that I used under design tools that I use to kind of automatically calculate and do this automatic design, well, this is literally the same thing you're going to report with. So in most cases, this layout is actually modeled after local kind of around Carolinas, Georgia, around kind of the southeast area, the municipal spreadsheets and tools. So we kind of put it in a format that would make sense to just copy this and report this as it is. Obviously you could input this information into one of those tools. But right away we can see, yes, success because of our swale, which is over storing, has extra volume than it needs. We have more volume achieved than we need. So this is kind of really that tool we've already looked at a number of times, which automates our design. We can walk through here and make some sort of change, and then this will amplify or kind of reduce the size of our facilities as needed to meet the inflow. But again, this is also just the reporting that we could use. All right, so we looked at a bunch of results. We can see how well things perform. What about that input, the input mistakes? How is this all working? Well, one, again, something else we've looked at in the past is templates. If we have put this model together using templates, which we have set out for our area, let's say if I have a template for urban residential development using SCS, let's say, or maybe I have these green street bioretention systems. By setting out these defaults being vertical walls, okay, and it's 1.2 feet deep in the ponding area, when I create the model, right, these standards will be used. So this is one way that from the start of a model, you can make sure you're adhering to the design practices. So something else we could look at might be profiles, long sections of these systems. So we're going to see how they're all behaving, how they all connect. So under flow paths, you see the magenta line shows me the flow path through the system. So I could right-click and show profile. You'll see there's also an option to auto-size these pipes or systems. All right, so right away, great, I happen to have these systems. They all line up. You see they all connect there at the invert of those manholes, daylight out appropriately into our facilities. I can, of course, play this simulation through. Maybe a more zoomed in, a shorter flow path might be this one here. So I'll make this bigger. We get the idea of flow in this system. You see it fills up the under drain, this filter. It's actually separate, right? It's not, we're not just assuming that this is a high roughness area. We're actually looking at volume storage and flow in that filter material. And there's also the ponding zone. You see we go through time how this fills up. So this is showing us the results, how things behave, but also how well the system is linked together. I think I've shown before, you can actually edit directly within this dialog. So within the profile, you could edit one of these items and it will reflect immediately in the profile. I'm not going to make any updates because I want to not have to run the model again. If you, of course, change something, you can just run it again and then look at those results. So these profiles are great. Something else we have in this soon-to-be released version is XP tables. So tabular view of really anything you want to see. So a couple of items here that might be, I guess, Excel plus. You know, this is kind of the standard, right? Excel, being able to look at information in this format. You can, of course, drag and drop columns. You can move columns around. Important items here might be, I want to change, you know, let's say time of concentration is all set at 9 minutes. Well, that's not right. There are some design tools we could use to update that. Maybe I know that things need to be set at a default of 10 minutes. Well, maybe I could come in here, I could say 10. Okay, well, I could maybe highlight a range of cells. We have this option here, pretty interesting. Make these 10. I can also just add 10. So you'll see this will allow me to add 10 or multiply by a factor. So pretty useful. So kind of a step beyond just copying and pasting around to and from Excel, to and from different tabs, different tables. So different things we can do. You see there's a whole range of different, in this case, inflow. You see the inflow icon here. So I'm only right now looking at inflow areas. Though in the same graph, you could look at multiple different items. We could change this so that the inflows or junctions are shown. By default, we have these tabs set up that show, this is called junctions and this is the default view. You could add new tables and have whatever combination of results or input you want to look at. So a good one might be stormwater controls. So with stormwater controls, I could look at so many different things. But we could have, only bioretention. That's all I'm looking at right now. And we can see, make sure the freeboard, perhaps, is that an input error, 4 inches? Well, that's for my porous asphalt. Maybe that's a 4-inch freeboard is what we want. So this is the way you could look at, right, input errors, if items obviously aren't the same or if there's big discrepancies. Okay, we could look at this. Connections, this would be the pipes. So we can get a look at all the different types, connections, slopes, roughnesses, really all the things that you'd really care to look at in the connections, pipes, channels world. As I mentioned before, all this information, especially these XP tables, you could not only just report, copy and paste into a Word document, but you could also, in this case, export this information out to Excel. So if that was just a different way you wanted to report it or get this information from another source, okay, that might be a commonly used thing to do. Would be to have your tables copied out, put into Excel, beyond just maybe a Word document. All right, so lots of different things we looked at. The really last piece would be, how does this kind of integrate into CAD? Well, we're going to at any moment be able to save this whole plan, right, as a DWG, as a CAD file, which can be then loaded into CAD, and obviously your site team can kind of lay into that, adjust their site grading, let's say, as needed, or the site layout. So that's kind of how we're going to close that loop of kind of disconnect, where you often might set something out in your spreadsheet or in a software tool, and maybe there's a bit that can get lost between what you've calculated back to CAD. I've already mentioned before that all of the input we have here in the software is directly connected to what's shown in the plan view, right? So in here, I can make any change. Let's say I want to replace this outline with something a little different. Right, so here's my new outline. All this information is updated. I could maybe, let's say I go to that. I want to change the new top area. I have the base, and this is actually going to be 1 to 4 slope. You see that the top area changes. This is all locked into plan view. So there's no disconnect. All we have to do now is really just save this so that our civil team, a site team, could look at it. So save this to AutoCAD and and we'll be able to kind of share that information with them. There was a question that I think just popped up was, is it possible to save this tables and graphs to PDF? Yes. Yep, you can absolutely do that. There's a couple different, obviously within those individual tools, there's actually also just kind of a master report. If you, if you print this, there's a way to actually we have a default report. Again, everyone reports a little differently, but we have a default report that spits out kind of all the input information out to this kind of master PDF document. So it's kind of one place you could do it. All right, well that concludes my kind of walking around all the different ways that we can review and vet and kind of just check out what we've done in the model to make sure that what we've done makes sense before we show someone else, or really kind of check to make sure that what someone just handed us makes sense as far as our design. Thank you very much for joining.